Bonjour and good morning. Welcome to WASA Distance Education Center and PLAR Science. So we're into week 2 of the PLAR Science, and it is term 1B. So as I mentioned last week, term 1B begins November 12th and it does not end until January 24th, 2025. So we're into week 2. Today is Monday, November 18th. So we have 2 classes this week, one today and then another one on Wednesday from 10 to 11. So for the term 1B schedule, we have, as I mentioned, Monday to Wednesdays, PLAR Science. Tuesdays and Thursdays, we have PLAR Math. And then from 1 to 2, we have the DC030, that's the co-op. And then there's a break from 2 to 3. 3 to 4, we have the grade 12 English, ENG 4E. And then we have from 4 to 5, the NBV 3E, which is Native Beliefs and Values. So if you're still wanting to register, you can contact your local DEC or call Michelle at WASA if you're not a PLAR student. For PLAR students, we have an announcement. We have a PLAR counselor, so she's dedicated into working with PLAR students. We have Mary McLaughlin. She started with us last week. She can be reached at the office number 807-737-1488. Her extension is 2224. And you can email her at mary.mclaughlin@nnec.on.ca. The online application form, that is still up and running. So if you do not have a hard copy, or if you're unable to fax your application, you can still use the online application form. All you need is an email to submit it. Students can also register for independent learning courses at any time during the school year. However, you have to complete the course on or before June 13th, 2025. And again, a big congratulations to the winners of the Term 1A draw. So we will continue to hold 2 student draws, one for students who earn a credit and one for those who submit work. So make sure to submit your work to your teacher to be entered into the draw. Students that are working on multiple courses will have their names entered for each subject in which they submit work. So we had one of our winners from Wepakwe. So Christella got the Kelly kettle. Then we have a student from Sioux Lookout, and she received the Under Armour backpack. And that's our principal holding the prizes. As a reminder to PLAR students, you still have a choice to complete an open book culminating activity. So if you prefer to do that instead of the key questions in the lessons, even if you have already started a lesson. I had one student who started lesson 1 in PLAR history, and then I mentioned that if you want, you can try the culminating activity for PLAR history, and he completed it. Okay. Passing mark, you need to get 50% and above. The culminating activity can be emailed to the DEC or to you, and supervision is not required. That means you don't have to be at the learning center to do the culminating. Students can take the culminating activity home to complete. Successful students, as I mentioned, 50% and above, will receive their equivalent credits, and then you can go ahead to do the senior PLAR and then move on to your senior credits. If the culminating activity is not passed, the key questions in the lessons must be completed, and you can take the culminating activity again. So it can be retaken, and you're permitted several attempts to pass the culminating activity. If you're still not sure about trying the culminating instead of the key questions, feel free to ask for a sample test to review the format of the culminating activity. So you can contact myself for the PLAR Science, History, and Geography, and you can contact Bonnie. She looks after the PLAR Math and English. So students who are choosing to complete the lessons and key questions in PLAR, you can expect that all of the packages, so all PLAR packages, are the same. So whether you enrolled in Radio Zoom or whether you signed up for IL, and you can still continue where you left off. So if you have previous versions of these lessons, I will accept the submitted work. So if you have the 2023-24 and you started working on the key questions, then I don't want you to start over again. You just continue where you left off. I can send you the most current version of the 2024-25 lessons. So you can see there are 5 lessons. Astronomy, there's one for biology, there's one for chemistry, there's one for physics, and one for environmental science. So if you have decided to do the key questions from the lessons, make sure you have these 5 lessons. If you're unable to participate during our Zoom classes, you can watch our classes on YouTube. So WASA Distance Education Center, we have our own YouTube. Term 1A and 1B classes are in there. Each course will have its own playlist where the broadcasted lessons can be accessed. So you can check it out and click the subscribe button. So here is what it looks like. So you can see right now it says home. What you want to do is you want to click playlist. And when you click on the playlist, these are the created playlists starting with PLAR Science, PLAR Math, NBV, that's the Worldviews and Aspirations of First Nations, the Grade 12 English, ENG 4E, DC 030, the PLAR Geography is there from last term, ENG 4C, PLAR English, PLAR History, Grade 12 Math, the MAP 4C, Foundations for College Math, and the OLC 4.0. So this is where you will find all the classes. So for term 1A, 1B. So make sure you could click the subscribe button. That way, if you subscribe, whenever a new video is added, it will notify you. If you don't have access to internet or Wi-Fi, you can still request a USB of classes. So if you want your PLAR Science classes, I can upload it on a flash drive, and you just have to have somewhere to put your USB. So you need a USB port, and then you can choose the lesson and the key questions that you want to view. Also NNEC students, so that includes WASA students. If you like, you can have your own nnecschools.org email. Some of you already have it. If you forget your password, let us know, we can reset it. Or if you have been trying to get in there and you can't, just let us know. We are able to activate your email. First thing you should do though, if you're trying to get in there, is to sign out of all accounts. Sometimes you're signed in from a different email account, and that's why it's not letting you get into that account. Once you're in there, you have your Drive. You can go to Google Classroom. You can have access to docs, sheets, and so on. Okay, once you have received your culminating activity, or if you're doing your key questions, you have several ways to submit it back to the teacher for marking. Scan your work if you can. You can use your iPhone Notes app, or you can also email it or send through Messenger. You can take a picture and send it through Facebook Messenger. When you email it to studentwork@nnec.on.ca. and then CC to the teacher that's marking your work. So if you are submitting PLAR Science, PLAR History and Geography, make sure you CC it to me. If you're submitting for PLAR Math and PLAR English, make sure you CC it to Bonnie. If you like, you can send it through Google Docs. You can share your answers or your document to the teacher. So right now, if it has a lock button, that means it's private only to you. Once you click the share button, it will unlock it, and you just have to put in the email that you want to send it to. You can still ask your DEC to scan or fax it for you if they can. If you're within the Sioux Lookout area, you can drop it off at 74 Front Street. We have an outdoor mailbox on the side entrance facing the post office. And if you have other questions or concerns, please do not hesitate to contact me. So as I've mentioned, we're in week 2. We're still working on lesson 1, astronomy. There are 80 key questions for lessons 1 to 5. There are 26 key questions for lesson 1. So we've completed 5 key questions already. So let's see how far we get today. This is the mark sheet for students who choose to complete the lessons. So for astronomy, as I said, there are 26 key questions. Then it follows to biology. You notice that the numbers continue, so 27 to 40 is lesson 2, then 41 to 63 is chemistry, 64 to 71 is lesson 4, which is physics, and then for environmental science, 72 to 80. So you might be doing the key questions, and halfway through you may decide, you know what, I'd like to try the culminating activity. You have that option. And for those of you who complete the culminating activity, here is the mark sheet. So this is what it looks like. There are 5 parts to the culminating activity. So you get a set of questions for part A, which is chemistry. Part B is in biology. Part C, astronomy. Part D, physics. And part E is environmental science. So this person tried the culminating instead of the key questions, and this person received 89%. So that is a pass. Remember, 50% and over is a pass. So we looked at page 5, the scientific method, or stages of the scientific method, on Wednesday. We will continue today, beginning on page 10, what is astronomy? Our learning goals: I can describe the planets and other heavenly bodies that make up our solar system. So keep that in mind. So the scientific method that we looked at on Wednesday is just a way scientists study and learn about the world. So first they notice a problem or question, then they collect information about it, and then they come up with a possible explanation or guess, and that's what we call a hypothesis. So finally they test the hypothesis by doing an experiment to see if it's correct or not. So remember the steps: question, hypothesis, then the experiment, then the conclusion, and so on. Okay, so let's look at page 10. What is astronomy? So astronomy is the study of things like the sun, the moon, stars, planets, comets, galaxies, even mysterious black holes that make up the universe. We have a term here. It's astronomer. That's a person. It is a scientist who mainly studies space, including stars, planets, and galaxies. So throughout history, many cultures have watched the stars and planets, and they've learned to predict events like eclipses by observing the sky. So here's a picture of a Canadian astronomer. His name is Arthur Bruce MacDonald. He's a Canadian astrophysicist or scientist who studies space and stars. He is the director of the Sudbury Neutrino Observatory and became famous for solving the solar neutrino problem. Another term here, you can highlight it if you want in your book. Space is everything in the universe beyond Earth's atmosphere. So it will include things like moon, planets, man-made satellites, other stars, the Milky Way, galaxy, black holes, radiation, and distant galaxies. So everything beyond the Earth's atmosphere is space. Next is the universe. So anything that we can touch, see, feel, measure, or detect. And that will also include living things, planets, stars, galaxies, dust clouds, light, and even time itself. Before the universe began, time, space, and matter didn't exist. The universe has billions of galaxies, and each galaxy has millions or billions of stars. So no one knows exactly how big the universe is, but we do know that the part we can see is at least 93 billion light years across. Now, a light year is the distance light travels in a year, so about 9 trillion kilometers. The universe hasn't always been this big. Scientists believed it started with a huge explosion called the Big Bang, which happened nearly 14 billion years ago. And since then, the universe has been expanding quickly. That just means that the part of the space we see now is billions of times larger than it was when the universe was very young. When we study astronomy, we're learning more about the universe. So the sun, moon, planets, and stars are all part of the universe. In fact, everything that exists is part of the universe. So when you think about it, it just includes absolutely everything. Earth is part of the universe. So when we learn about the universe, we're also learning about Earth's place in it. So for example, the more we learn about the other planets in our solar system, the more we understand planets in general. And as we understand planets better, we also gain a better understanding of Earth. For many centuries, people believed that Earth was the center of the universe and that the sun and stars moved around it. However, this idea didn't easily explain how the planets move. To make it work, people came up with very complicated models to show how the planets could orbit Earth. Okay, so this is what people once thought, that the sun, so you have the sun, and that it revolved around the Earth. And for hundreds of years, people also believed that the world was flat. So it was Nicholas Copernicus. He was a Polish astronomer. He lived in the 1500s. He was the one who studied the sky, even though he didn't have any tools to help him. And through his observations, he became convinced that the Earth and the other planets revolved around the sun. At first, most people didn't believe his ideas, but today we know he was right. His ideas changed how people saw the universe. We now understand that the Earth isn't the center of the universe. It's just one small planet among countless stars. So here's the Earth. There's the sun. Okay, so the Earth is revolving. Next term is the word star. So a star is a bright ball of gas. What is it made of? Well, it's made up of hydrogen and helium, and it's held together by its own gravity. So inside a star, nuclear fusion reactions happen in its core, which produce light, or photons, and heat, along with small amounts of heavier elements. So the sun is the closest star to Earth. Like people, stars are born, they grow old, and eventually die. They begin their life in massive clouds of gas and dust called nebulae. One of the most famous nebulae is the Orion Nebula, which can be seen without a telescope. So billions of years after a medium-sized star like the sun is born, it starts to near the end of its life. So at this stage, it expands, so it gets bigger, and becomes a red giant. After shedding its outer layers of gas, the star collapses into a very dense white dwarf. Small stars can live for more than 10 billion years. Their deaths have never been observed, but they are expected to end their lives quietly and eventually fade away. The largest stars have a very dramatic endings. They expand into red supergiants. They then explode into a massive supernova. So the elements created inside the supergiant, like oxygen, carbon, and iron, are scattered into space. And these elements eventually help form new stars and planets. So remember, a star is luminous, it's glowing, and it's held together by gravity. The eye can only see 2,000 stars in the sky at a time, and there are stars that are hotter and cooler than the sun. Okay, the next term is the word constellations. So the heavenly bodies we see in space are groups of stars, but they form different shapes or patterns, and that's why they're called constellations. So early astronomers noticed these patterns in the sky, and then they organized them to track and predict their movements. These constellations help people in the past measure the seasons. So the movement of stars and other celestial bodies was tracked around the world, specifically in China, Egypt, Greece, Mesopotamia, Central America, and India. Many cultures created stories about hunters, warriors, queens, and kings, as well as animals like birds, bears, horses, based on the figures they saw in the sky. And they used these stories to teach their history and explain their place in the universe. For example, Orion, it's named after a Greek hunter, and is one of the most famous constellations in the sky. It's visible in the night sky from November to February on the celestial equator. The constellation of Orion contains 2 of the 10 most brightest stars, with Rigel being Orion's brightest star. So it's one of the most easily recognizable constellation. Here's another one, the Big Dipper. Okay, that one, you may be familiar with it. Next word, galaxies. So almost all stars are part of a huge group called galaxies. So the sun is just one of at least 100 billion stars in our galaxy. Now our galaxy is the Milky Way. In fact, there are billions of galaxies in the entire universe. Galaxies were formed only a few 100 million years after the universe began, which is about 13 billion years ago. Back then, galaxies were smaller and much closer together. Collisions between them were common. When galaxies collided, they grew larger and they changed shape. Since then, the universe has been expanding. Most galaxies are moving away from each other at high speeds, except in galaxy clusters where they orbit around each other. So we live in one of the arms of a large spiral galaxy called the Milky Way. So the sun and its planets, including Earth, are located in the calm area of the galaxy, about halfway between the center and the edge. The Milky Way looks like a giant whirlpool that rotates once every 200 million years. It contains at least 100 billion stars, along with dust and gas. It's so massive, so it's so big that it takes 100,000 light years to travel from one side to the other. The center of the Milky Way is hard to see, but scientists believe it contains a supermassive black hole that pulls in anything that gets too close. A few years ago, the Hubble Space Telescope took a picture called the Hubble Deep Field, by multiplying that number by the volume of space in every direction, we can guess that there are millions of billions of galaxies with billions of stars in each one. And just for reference, a light year is a unit of distance, so not time, even though the name might sound like it's about time. It's a distance that light travels in one Earth year, so which is about 6 trillion miles or 9.7 trillion kilometers. Okay, next up is the Big Bang. This is a scientific theory about how the universe started. So the universe began with a huge explosion called the Big Bang around 14 billion years ago. Now, before this explosion, all the matter in the universe was squeezed into a space so small it could have been the size of a tiny pinhead. After the Big Bang, all the matter in the universe was spread out like a fine dust or mist. The particles were tiny, so small that we still can't see them even today. These are what scientists call subatomic particles. So scientists are still studying to learn more about these early particles. So after the Big Bang, the universe started expanding very quickly. If you can imagine the universe like a balloon being blown up, as the balloon gets bigger, dots on its surface move further apart, just like the objects in the universe. Even though most things were spreading apart, some particles came together by chance to form larger objects. So over time, more particles combine, creating bigger and more complex particles. Eventually, particles like electrons, protons, and neutrons formed, and then these particles combined to form the smallest atom, hydrogen, which has 1 proton, 1 neutron, and 1 electron. So this is important because when lots of hydrogen atoms gathered in one place, they formed stars. So the first stars were small, but some joined to make even bigger stars. These stars were like giant ovens with super hot insides, and then inside smaller hydrogen atoms were cooked and fused together under huge pressure, creating heavier elements like iron and nickel. Then we have the Hubble Space Telescope, or HST. It's one of the most well-known telescopes. It was the first optical telescope to be placed in space. Because it orbits above Earth's atmosphere, it can see the sky more clearly than telescopes on the ground, which have to look through the atmosphere that blurs starlight. This telescope is named after the astronomer Edwin Hubble and can observe the sky 24 hours a day. So here are some facts about the Hubble telescope. It orbits Earth at a speed of 5 miles per second. It was launched on April 24th, 1990 by the Space Shuttle Discovery. It was designed to stay in space for about 20 years. Now, we said this already. It was named after Dr. Edwin P. Hubble. He proved the universe is expanding, which is a key idea behind the Big Bang Theory. The Hubble is 43.5 feet long, 14 feet wide, and weighs about 24,500 pounds. It cost $1.5 billion to build. It orbits 353 miles or 568 kilometers above Earth. Every week, the Hubble sends about 120 gigabytes of data back to scientists. It gets its power from the sun using 2 solar panels, each 25 feet long. The Hubble can lock on to an object it's photographing, which keeps it steady to capture very clear images. Okay, and you can see that on the slide there. That's the Hubble telescope. So if you're following along in your book, if you look on page 16, there are support questions on that page. Remember, the support questions you do not submit for marking because the answers are at the end of the lesson. So you can try this one. In the space provided, write true if the sentence is true or put false if it is false. So there are 10 statements there. Number 2, match each of the following terms with the most appropriate statement. So your answer goes onto the left-hand side of the columns or of the chart. Column A says astronomy, Earth, Sun, Moon, and Universe. Column B are the descriptions. Revolves around the Earth, planets revolve around it, everything that exists, the study of objects in space, and revolves around the sun. So we can try key questions 6 to 10. So remember we did key questions 1 to 5 on Wednesday. Remember that when you're answering the questions, use the information that's provided to you along with your own knowledge and experience. You don't need to use internet or Wi-Fi to look up answers. And as I mentioned, send only pages 49 to 53 of lesson 1 for marking if you're doing the key questions. You do not need to send in the whole lesson. Okay, I'm only marking the key questions. So let's try key questions 6 to 10. So that would be astronomy, stars, Big Bang, and define the terms. Okay, key question 6, identify one reason. So just one reason that people study astronomy. You can start off with people study astronomy and then give one reason. Key question 7. This one has 2 parts. It says, what are stars made of? So you want to start off with stars are made of. So that's the first part of the question. The second part is, where are they made? So they are made from. Okay, you'll get full marks if you answer both parts. Key question 8. This is asking you what happens to big stars at the end of their lives. So make sure you're looking at the section regarding stars and you're focusing on what happens to it at the end of their lives. Key question 9. In 2 or 3 sentences, describe the Big Bang. So 2 or 3 sentences, and specifically you're talking about the Big Bang. Key question 10. It says, in 1 or 2 sentences, give a brief definition of the following terms. Okay, so I don't want a lot, I just want 1 or 2 sentences. So for example, let's say on the bottom here it says Hubble Space Telescope. You might say it's the largest telescope that orbits the Earth. Okay, here's the second part of it. Then star, then Nicholas Copernicus, and then the universe. Okay, so try those key questions 6 to 10. Okay, next up, so if you turn to page 17 of your lesson book, we are now looking at the solar system. So these days the word solar means seems to be everywhere. You've probably heard terms like solar energy or solar power, but what does solar actually mean? So it simply means related to the sun. So the solar system is a system that includes the sun and everything connected to it. So we're looking at the sun, everything that moves around it, like planets, moons, asteroids, comets, and meteoroids. These objects move in paths called orbits, and it's the sun's gravity keeps them in place. The planets don't produce their own light. That means they're non-luminous, but they reflect light from the sun. The sun, however, is a star and it produces its own light. So the star is luminous. The planets are non-luminous. Our solar system has 8 planets and 1 star. Scientists estimate that the edge of the solar system is about 9 billion miles or 15 billion kilometers away from the sun. So for example, luminous objects, we said it's the sun, stars, a bulb, those are luminous. Basically, it gives their own light. Non-luminous, they do not create light. But how can we see them? For example, the moon, we can see non-luminous objects because of the light reflected off of them. So how can you tell the difference between a star and a planet? Well, stars are very far away, and like we said, they give off their own light and heat, while planets are round objects that orbit around a star. So when you look at the night sky, stars usually twinkle, but planets shine with a steady light, and they look bigger because they're much closer to Earth. So without a telescope, you can see 5 planets. You can see Mercury, Venus, Mars, Jupiter, and Saturn. Okay, you can see these planets without a telescope. The other 2, Uranus and Neptune, these 2 are just too far away to see without a powerful telescope. Okay, so remember, a star has its own light. They're larger in size and they're fixed, whereas the planet has no light. They're small in size and they revolve. So the planets closest to the sun are Mercury, Venus, Earth, and Mars. These are what we call the inner planets because they are near the sun. They are also known as terrestrial planets because they are small and they are made of rock. Jupiter, Saturn, Uranus, and Neptune are what we call outer planets because they are farther from the sun, and they are called gas giants because they are big and they are made mostly of gases. For many years, Pluto was considered a planet, but in 2006, scientists reclassified it as a dwarf planet. Astronomers are searching for a new planet in our solar system after finding evidence of it on January 20th, 2016. Scientists think this planet, called Planet 9, is about 10 times bigger than the Earth and 5,000 times heavier than Pluto. So let's look at some more terms here. Planets, we said, are the biggest objects in the solar system besides the sun. There are 8 of them. They orbit the sun, including our home. So Earth is also a planet. Moons, most planets have moons, and moons also orbit the planets. Asteroids, these are large chunks of rock. Most asteroids are found in a belt between the planets Mars and Jupiter. Comets are made of rocks, dust, and ice. They have a small head and a long tail that can stretch millions of miles into space. The tail always points away from the sun. So comets move around the sun in long oval-shaped paths. The most famous comet is Halley's Comet, which takes 76 years to go around the sun once. Meteoroids are small pieces of rock, usually as tiny as grains of sand, but some can be as big as boulders. There are billions of them in the solar system. When a meteoroid enters the Earth's atmosphere, it glows brightly because of friction and looks like it's burning up. While it's glowing, it's called a meteor or a shooting star, and we see it as a streak of light in the night sky. Now, most meteors, they burn up completely, but a few will reach the ground. When they land on Earth, then they are called meteorites. Okay, so you start off with meteoroids, then meteor or shooting star, and then if they land, they're called meteorites. Okay, finally we are looking at page 19, the sun. So the sun gives energy to all plants and animals on Earth, and its gravity keeps our planet in its path around it. The sun is the closest star to Earth, making it the brightest object in the sky. Its light is so strong that other stars are not visible until the sun sets, and the sun produces energy through nuclear fusion. So nuclear fusion, that's just how the sun makes energy. So inside the sun, it's so hot and it has so much pressure that tiny particles called atoms, they basically smash together and join to form new, bigger atoms. So during this process, it releases a huge amount of energy as heat and light. Inside the sun, high temperature and pressure cause substances to join together. This process creates heat, light, and other energy that spreads out into space. So scientists think that the sun will keep making energy for about 5 billion more years before it runs out of fuel. So if you look on page 19, you can see different parts of the sun. There's sunspots. These are areas on the sun's surface that appear darker because they are at lower temperature than surrounding areas. There's also the corona, which is the outermost surface of the sun. It's visible during a solar eclipse and is much hotter than the visible surface of the sun. The core is the hottest part of the solar system. There's the chromosphere. It is a reddish color but is not visible to the eye. That means we can't see it. Photosphere, this is the visible layer of the sun, but it is cooler than the outer two layers. Prominences, these are large flares of energy that loop back to the sun's surface. And then flares, these are bursts of energy that flash off of the sun's surface. Okay, let's try key question 11. For how many years can the sun continue to supply us with energy? And key question 12, what temperature does the sun reach at the corona? Okay, so remember, you have to read page 19. That's about the sun, in order to answer these key questions. Okay, we still have about 5 more minutes left, so let's continue on to planets in the solar system. So a planet is a large object that orbits a star and has enough gravity to shape itself into a round form. We already said there are 8 planets in our solar system, and some can be seen without a telescope. In 2006, the International Astronomical Union, IAU, created a new definition for planets. This led to some controversy, which meant that some objects like Pluto was no longer considered a planet. So there are 2 types of planets. We have large gas giants and small rocky planets. The 4 rocky planets, or terrestrial planets, closest to the sun are Mercury, Venus, Earth, and Mars, or we can also call them inner planets. The 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, these are farther out, and they are called outer planets. 6 of the planets have 1 or more moons that orbit them. So more than 2,000 planets outside our solar system are called exoplanets. They've been found in the Milky Way. So these planets, they vary in size from ones just a little bigger than the moon to gas giants that are twice the size of Jupiter. So over 3,700 confirmed exoplanets. Each planet in our solar system orbits the sun in its own path. So the closer a planet is to the sun, the faster it takes to complete its orbit. So at the same time, the planets are spinning on their axis. So a rotation is one full spin, while a revolution is when one object moves around another. So the spinning or rotation of a planet causes day and night, while the orbiting or revolution gives the planet its seasons. So you can see there's the bicycle, there's the spoke. So that's the axis of rotation. So as this goes around, that thing is spinning. So remember, Earth's rotation is what gives us day and night, and the Earth's revolution, this creates seasons. So the rotation, as we said, it creates day and night. So a full rotation for Earth is 24 hours. The revolution or orbit, so it's about 365.25 days. So that equals a year. That's our year. Okay, and finally we can do how to remember the order of the planets. So to remember the order of the planets from the sun, you can use a mnemonic. That's just a helpful phrase or clue. For example, my very educated mother just served us nachos. This represents, so the M is for Mercury, V, very, for Venus, educated, so the E is Earth, mother for Mars, so the M, just for J is Jupiter, served, so S for Saturn, us for Uranus, and nachos, so N for Neptune. Okay, and you can come up with your own clue or helpful phrase. This is the one I remember from a student. It says, Mom visits every Monday, just stays until noon. Okay, that was a very long time ago, but it stuck. Okay, and there are planets or quick facts on page 22. So we'll stop here though, and what we'll do is we'll look at some key questions. So the quick facts, if you turn to page 22, it tells you a characteristic of each planet that makes it unique. Okay, so for example, Mercury is the closest planet. But don't just say Venus is the second planet, Earth is the third, Mars is the fourth. Pick a unique characteristic. And key questions 14 and 15, you just have to name the 4 planets that are closest to the sun, and then the 4 planets farthest from the sun, you just have to name those. Okay, so we'll stop here. So we completed key questions 6 to 15 today, and we'll continue with lesson 1 on Wednesday.